Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems from the question paper CSIR National Eligibility Test held on February 28, 2025. Today, we discuss the solution of a problem from the section Complex Analysis, and this problem is related to the concepts of harmonic functions. And this question is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 704116. This question is suitable for all these examinations. Right. The given question is, let D is equal to the set consisting of Z is equal to X plus IY, which are complex numbers, such that mod Z less than 1 be the open unit disk and F be a map from D to C, which is given to be a holomorphic function such that f of 0 is equal to 0. Let psi of z is equal to mod of fz square, mod fz square, and del square s by del x square plus del square s psi by del square psi by del x square plus del square psi by del y square is identically equal to 0. Which of the following statements is false? We have to find out a false statement. We are given 4 options. Option 1, f can be extended to c as an entire function. Option 2, f must have infinitely many zeros in D. Option 3, f is not a polynomial. Option 4, exponential of f, that is e power f, cannot take every complex value. Right. Let's now discuss the solution of the problem in detail. We have D, a unit, the unit open disk. We have a holomorphic function, that is an analytic function, f from D to C, satisfying f of 0 is equal to 0. Let f of z is equal to u of x comma y plus iv of x comma y. So, u and v are real and imaginary parts of this analytic function f of z. Since f of z is analytic in D, its real and imaginary parts, that is u and v, are harmonic functions. What do you mean by harmonic functions? That is, they have continuous first and second order partial derivatives and satisfy Laplace's equation. So, the real and imaginary parts of an analytic function are harmonic. Right. Given psi of z is equal to mod fz square and del square psi by del x square plus del square psi by del y square is identically equal to 0. So, we have to find out del square psi by del x square. So, psi of z is mod fz square, fz is u plus iv, mod fz square is u square plus v square. Right. Differentiate partially with respect to x. Psi x that is dou psi by dou x is equal to 2u into partial derivative of u with respect to x, ux plus 2v vx, right. Differentiate again partially with respect to x. Psi xx is equal to 2ux, u with respect to x, ux, 2u, differentiate partially with respect to x of ux, that is uxx, plus 2vxx, 2vxvx plus 2vvxx, right. Similarly, like this we write. Similarly, psi of yy is equal to 2uy plus 2u into uyy plus 2vy plus 2v into vyy. Now adding. If you add, you will get psi xx plus psi yy is equal to 2 is common, ux square, uy square, plus 2 is taken out, u take common between these two, u into uxx plus uyy in brackets, plus vx square plus vy square plus v into vxx plus vyy. Now, what are u and v? U and v are harmonic functions. They satisfy Laplace equation. Therefore, uxx plus uyy is 0, vxx plus vyy is equal to 0. Then this will be equal to 2 times ux square plus uy square plus vx square plus vy square. And these terms will become 0 because u and v satisfy Laplace equation. We continue in the next slide. Right. That's what we have got. Right. Now, it is given del square psi by del x square plus del square psi by del y square is identically equal to 0. That means ux square plus uy square plus vx square plus vy square is identically equal to 0. Is identically equal to 0. Sums of squares is identically equal to 0 means each must be equal to 0. So, this will imply ux is 0, uy is 0, vx is 0, vy is 0. Now, ux is 0 means u is free from x, uy is 0, u is free from y. That means these two put together, u is free from both x and y. Then what will be u? U will be a constant. Now vx is equal to 0, vy is equal to 0, v is constant. So this will imply u and v are constant functions. If u and v are constant functions, f of z is equal to u plus iv is also a constant. Is c a constant for all z belongs to D. Right. So now given f of 0 is equal to 0. F of 0 is equal to 0. So f of z is equal to c. In this, put z is equal to 0. So that will be f of 0 is equal to c. But f of 0 is equal to 0. Therefore, c is equal to 0. Therefore, f of z is equal to 0 for all z belongs to D. That's what we got. Now, we call on option 1. F can be extended to c as an entire function. Yes, this can be extended to an entire function. Right. We have f of z is equal to 0 for all z belongs to D, a constant function on D. Clearly, we can extend it to f of z is equal to 0 for all z belongs to C. Right. And since every constant f of z is equal to 0 is a constant function, and every constant function is an entire function, thus it can be extended to C as an entire function. Thus, option 1 is true, but we have to find that statement which is a false statement. We continue in the next slide. Right. Option 2. F must have infinitely many zeros in D. Yes, this is trivially true. Why? Because f of z is equal to 0 for all z belongs to D means every element of D is a 0 of f of z is equal to 0. So we have f of z is equal to 0 for all z belongs to D implies each element of D is a 0 of fz. This implies f has infinitely many zeros in D. So option 2 is also true. But we have to find out that statement which is a false statement. Option 3, f is not a polynomial. F is not a polynomial. Clearly, f is a polynomial. Why? F of z is equal to 0 means 0 plus 0 z plus 0 z square plus so on and so forth. It's a polynomial. Clearly, f is a polynomial. So, but it is given f is not a polynomial. Therefore, this is the false statement. So, option 3 is false. Our answer is option 3 because we have to find out that option which is false. Go to the option 4. Exponential of f, that means e power of f cannot take every complex value. Yes, we have f of z is equal to 0 for all z belongs to D. So this will be e to the power of f of z, that is equal to e to the power of 0, that is equal to 1 for all z belongs to D. For all z belongs to D, it takes the value 1. So it is very clear that e to the power of f of z will not take every complex value. So clearly exponential of f cannot take every complex value. So option 4 is true because it cannot take is given, it we have also it cannot take. So therefore option 4 is true, and we have to find out that option which is a false statement, that is the option 3. So the answer to this question is option 3. That is the detailed discussion of the solution of this problem. This problem is a very simple and straightforward question, and which it talks about the properties of analytic functions, and it talks about the harmonic functions, and it uses the real and imaginary parts of an analytic function or harmonic functions. Right. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will certainly meet all of you again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.